Hey folks, I'm Chuck Black. We are doing 52 weeks of Python. We are in week 61. I guess these are all bonus weeks because the information about Python is so fun. I can't stop telling you about it. So what are we talking about this time? We are talking about how nice it would be to be able to create graphs like this with the data that we've captured using host monitoring, device monitoring, and service monitoring so that you can see what response time and availabilities are like over time and record that somewhere being in the database. So what we're going to talk about is how that stuff gets stored in the database and the means of doing that. We're going to look at the code that actually does that. Here we're looking at a RESTful API that makes requests for the data, but the actual database code is a little bit more interesting. Here's the new stuff that's been added. Every time we set status for hosts or services or devices, we're going to actually add something to a new table or collection called host status, device status, service status, and we will just be writing that out constantly. And then whenever the user interface or whoever it is that's requesting it via the REST API request for stuff, we're going to explain what this cool database function is and how it gets us the data that we're interested in so that we can return it. So that's what we'll be talking about. Hopefully it will be interesting and understandable to you. So let's get started. So for this upcoming discussion, we're looking at how to take what we have today with our Quokka Prime, or I guess when I put this and created it, I called it Quokka Lite. I should probably change that, but we want to go from this where we can look at our devices, we can look at our hosts and see all the hosts, we can look at our services and see all of the services. This is good for getting a snapshot, and in fact, it can be useful when I want to do things like sort based on the availability of particular hosts in this situation. Maybe I want to sort on the response time so that I can see the best response times and the worst response times. So this is all really well and good, and it's useful for giving me a snapshot of how things are right at this particular moment. But what if I want to see how things are behaving over time? In other words, I don't want to just see something like this for host, but I want to be able to click on a particular host and say, okay, show me how that host is doing over time. So in this situation, this screen that we're looking at is Google Home, and we're looking at its response time over time as well as its availability. And likewise, I've done the same for a device, and I've done the same for a service. Now I have popped out different tabs for my Chrome in order to look at this. The actual application, just so that you're aware of it, is going to look, when you look at it, it's going to look something like this, where I say, okay, I want to look at how this Pixel 3a XL is doing over time. I can see, well, it's not even been available over time. Maybe that was a bad one to pick. How about this Lenovo Yoga? Let's see if that one has come and gone. Yeah, that's my laptop. It periodically is available and sometimes it's not. And if I go return to hosts and I look at a different device here, then I can see, yeah, here's some availability. I can see that this is actually getting cut off a little bit. Maybe I need to fix that. But in general, you can see that we have availability over time. In other words, it's not just one snapshot. In fact, the one snapshot is probably represented by what's here over at the far right, because as you can see, it's 8:44 in the morning, and this is saying 8:40. This is going to about 8:44. So how can I get something like this? And I was showing you that that's the way it is for hosts. The same is true with services. I've added this extra action button so I can go for a particular service and look at its response time. I can go back and do the same for my devices. For those of you that are familiar with the original Quokka, I've done devices a little bit differently in my Quokka Prime, but you can see here the availability and the response time for my CSR sandbox that I'm communicating with. So that's what it normally looks like when you're going back and forth. These little ones I did mainly for aesthetic purposes. So the question is, how do we go from this thing where we're looking at a bunch of hosts, let's say, to a particular display of one of these hosts? Let's choose this one again. How do I go from the original table to having this? And the answer is we need to store the data over time in order to do that. And the way that we do that is we need to create tables in our database in order to store that data. So let's look at what that looks like. So how do we go from this, where we have snapshots for every single one of these, into something such as this that I was just showing you, which has data over time? Or maybe a better example would be whatever I'm looking at right here, which is my Google Home device, where you can see my response time and availability. And the answer is we store the information in the database. So we're going to accumulate all of the measurements for response time and availability for this particular device, and not only for this device, but for every host and for every device and for every service. So what does that actually look like when we talk about the database? Well, let's take a look at that. So here we are. I've cleared my screen. I want to show you how to get in and look at the database now. I've shown you this stuff before a little bit, but basically for Mongo on Ubuntu, as I'm doing it, I type in Mongo. This is giving me the Mongo database shell, you can see, and now I want to go and use my particular database. So I'm going to say use QuokkaDB. This is what I've named my database. So now I'm at QuokkaDB. And the way that you can display things, if you're familiar with SQL, then I would do a select statement, but we're not in SQL. This is a no SQL or not only SQL type of database. Mongo is. So what I'm going to use is their syntax. So I'm going to say DB, that's my database, dot, I'm going to say hosts just for kicks, and then say dot find. And what this is going to do is it's going to display for me all of the hosts. Now this is a little bit hard to read, but if you look over here, you can see I've got a host name. You can see I've got a last heard value. I don't really have room for that. Now I say, gee, wouldn't it be nice if I could look at this without this ugly object ID thing right here? So let me show you how you can get rid of that. I would say exactly the same thing that I said before, but I'm going to give search parameters, which are empty. That's my curly brackets there. And then my display parameters are going to specify that I want to not care about the underscore ID field. So I'm going to say underscore ID, and what I'm going to do is I'm going to say 0 and put a close curly brackets there. And now what this is going to do is it's going to display the same thing but without the object ID. So you just learned a little bit about how to do Mongo in order to get rid of fields that you don't care about. Now if I only cared about certain things, then I could do exactly the same thing, except instead of doing ID, I would specify the name of the field that I'm interested in. So host name, let's say, and I'm going to say 1. That means true. That means I want to display that. So let's see what happens when I do this. So here you see, by default, it always does ID, so I probably should have left ID in there, but it's printing out the host name for me. So if I wanted to add one more thing like response time, I could do that. I'm going to actually use this and get rid of the ID, comma, host name, colon 1, and then response underscore time 1, and we'll add availability as 1 also. And let's see if I've typed this correctly. So here you can see a certain number of my hosts. It only prints a certain number of them by default. But here's the host name and the host name and the availability, true, and the response time, whatever that value is. Now, if I wanted to look at something for only a particular host name, let's choose one host name here. So I could say in the first thing, this is where you do your search criteria. Now I know we're getting into Mongo stuff here, but this is, if you're going to work with the database, you're going to need to learn stuff like this. So let us do Google-home.home. I'm going to hope that I printed that correctly. And sure enough, here's my one item right there, okay? Do you see that? That is my one item in my hosts table. I'm looking at my hosts table. It's not really a table. It's a collection in my Mongo database, but that is what it looks like. Now, I wanted to show you something different, and I'm going to do a few spaces here. I'm going to change to not look at the host table, but I'm going to look at the host status table. So this is my table that I created to print out all of this data. So I'm going to ignore all of this stuff. I want to see the host name, response time, and the availability. Okay, so this is good. Remember right here, I did a find on hostname Google Home on the hosts collection, and I get one entry. And that's reflective of the fact that in my table here, where'd my table go? This is my table. It's not my table. This is my, I'll just do this. In my table here, I have every single host, but I have one entry for every single host. You can see that there's only one Google Home. It's a snapshot of what is happening right at this moment. And when I look at Google Home in the host table, sure enough, there's one entry. In my host status table for my Google Home.home host name, I have many entries, and I'm not printing out here the timestamp. I could do that. Why don't I do that right now? I'm going to add availability, comma, time. I think I called it time. And I need to set that to 1. I'm hoping I did this right. Okay, so this is good. So here you can see the time. So now I have, this is basically the information that I care about in the database. I have my time, I have my host name. I need that in order to sort it. I don't want to have a separate table for every host name. They're all in the same table. I have availability and I have response time. Now, if I was to just show everything in the table, just so you're aware, and I want you not to be thinking differently or incorrectly, I'm going to go back and get rid of this search criteria. So my search criteria is going to be empty, and I just want to see host name, response time, availability, etc. And now when I show it, you can see all of my host name, all of this stuff is in the same table. I can type IT for more and more and more and more, and you can see it's giving them to me pretty much in sorted order. But this is from a couple days ago when I first started to do these, started to implement the code that stored this stuff. So this is from actually 2 days ago. It's July 9th right now. You can see up at the top. So this is kind of in the order that they were entered in. And we will look at, I'm not going to show you it here. You can do it here, but we're going to look at in the code how we actually will do things like sorting so that we only get the most recent stuff, and how we filter by the host name. So let me just go back, and basically this is going to be what we're doing, is we're going to be getting all of the entries for a particular host name, and we're then going to be printing it out when we do something like this. We're going to be getting everything for Amazon 59B whatever, and we're going to be gathering all of that data. Now, the two things you need to be aware of: when I get this data, my REST API, I'm going to be returning the most recent certain number of data points, and also I need to, and I'm only going to get, I need to sort it as well. So that's it. That's two things. Number one, I need to sort it so that I have it in time-based order, and then I need to get only 24 entries. And we'll show you how to do that when we look at the code. Okay, so let's look at the code that actually stores this data, and you're going to be amazed at how simple it is. This is the code that we have already written. This is the code that updates hosts in the database. So every time a database is pinged and its status is acquired, response time, etc., then it gets written into the database like this. And you can see that this handles adding an item to the database for when they're discovered. And this is the item, this is the command, this is the code that actually writes out the new information. And that's what we've had before. The stuff I've added that's new is this stuff right here. In fact, I'm going to show you something over here in the gutter by the numbers in PyCharm. This is really handy. I can ask it to annotate. Now it's annotating it with git blame. That is the git blame part of it is how it is linked with git, so you don't have to worry about that. But this is going to show me when I created this stuff. This stuff I created May the 4th. For those of you that do it backwards, here in the United States we do the month of 5, which is May, and that's the 4th. You can see that's when I added all of this code. On the other hand, this code I added yesterday, and so let's look at this code that is part of set host right here that I was just discussing. This is the stuff that I added. This is all that I needed to do in order to write data into this new database table or collection, whatever you want to call it. In Mongo, we'll call it a collection because that's what it's called. And the nice thing about Mongo is I did not have to create this table anywhere. I did not have to create code that defines it. Remember, in SQL, you need to create classes with very specific predefined information about what's in every single field. It's way, in about 10,000 more ways simpler in Mongo. All I did was I added host underscore status. Even though it didn't exist, it created the table for me and it inserted this thing. Now, why am I always doing insert? Well, remember, this is time series data. We always do inserts because if you recall, I can't remember if I have it. Here you go. We just keep adding new entries, and the next time we get an entry, we add the next entry. So we just keep adding entries forever and ever. And you may say, well, if you add it forever and ever, isn't your database going to get over full? And yeah, we'll deal with that in a subsequent lesson where we trim things that are old. It's a pretty simple thing for us to do. But this is all I had to do. I create this. What is it? For those of you that are brand new, of course, this is a dictionary. This is the key, and that's the value that it's putting in there. It's putting in the time, the host name, the availability, and the response time. That's the same stuff that we're looking at here. Time, you see here, host name, availability, and response time. That's what I'm adding for this entry in the database table. And all I need to do to add a line into the database is say insert one, and it will happily insert it into the database for me. Now I'm going to go through this chronologically, meaning this is the order that things generally happen in the operation of the product. You'll see up here that I have some stuff that is defining. You know what? I'm changing my mind. I'm going to talk about this stuff. This is the only other thing that I did. Of course, I did this for hosts, and then once I got it working, I replicated what I had done for devices and for services as well. But this is my getting of host status. What is that used for? Pause it right now if you want to think about who is going to be calling get host status. And the answer is our REST API is going to be calling get host status, because quick peek right here, I created a REST API host/status. It's our host status endpoint. It's a get, and what is it going to do? It's going to get the information about the host status. You can see, and that's what get host status actually is. So let's look at it, since I said we were going to stay there. What do we have to do this really difficult job of going into the database, looking at the table, sorting through every entry for this particular host, and then getting a certain number of what we call data points? Because you'll notice this would look really stupid if I had it over the entire lifetime. Now, you could have a little button up here that would say the last half hour, the last 24 hours for all time if you wanted to. That's extra credit, and it would be fun to do, but I'm just trying to get you just up to the point where you can do something like this. So we're not worrying about that right now. Basically, the number of data points is going to be passed in. It will be something like 24, I believe. That's probably the number of these dots that you have here, which is corresponds to the number of different readings that we have here for the response time. What do we have to do in order to do all of this fancy, heavy database lifting? The great news is, guess what? The database does this for you. This is why we love databases and why you should learn about databases, even if you're not using them right now. Having this level of knowledge will be useful, and this code you have, you can always look back at it if you do decide to implement databases. How do I get data from the database? I do a find. Okay, that's what we've always done. This will get you multiple items. If I want just one, remember down here in set host, I did a find one. That got me the one entry in the host table for that host. Here I'm getting host status, so I'm looking in the host status table, and I want to get everything, except I'm not getting everything. What am I getting? I'm getting everything that matches the host name. So this is my filter criteria, okay? The first dictionary that I provide in here for the find, is going to identify what I want to search for. I can have multiple items in here. I can't remember if we've done that before. I think we have, but this is how I can get just based on the host name. So I get all of those. The next thing I'm going to do, remember this is method chaining, so it's going to take everything that it finds with this particular host name that got passed in. It's going to sort it, and how is it going to sort it? On what field? It's going to sort it on the time field. You see we have a time field here, and even though I'm storing it in a string format and not a date type object, for those of you that are more advanced, the good news is that this is going to be alphanumerically, I don't know what the right word is, lexicographically sortable, so that I can do a descending sort and get the most recent items. So what it's going to do, because that, I didn't install an index on the time field. I need to do that because that is what I need to do. So I need to make sure I go through and update that. But even if I don't have an index on it to make it faster, it still works fine, and it will sort based on time. And I'm saying -1. That means it sorts it in descending order. That means the most recent items are going to pop up first. So at the very beginning, I have the most recent items in this time series data based on this time. You can see this is printing it in the order that it went in, which is the opposite of what we will be getting it back from our request here. Now, the last thing that we do is we only want to get a certain number of pieces of data. So we are going to only get the number of data points that was requested. And once I have done that, I now have all of these status records, which are nice and handy and pretty much regular Python data. Now, the only difficulty is this. I could return this, but remember, and let me see if I can scroll back here far enough. Still scrolling, still scrolling. Remember when we looked at this, when we looked at it before? This is looking at hosts. If I look at hosts, do I have host data? Anyway, yeah, this is just for hosts, but do you see that I'm actually getting something here which is not a normal JSON-able item? This item here is a class called object ID. I don't care about it. It's an internal piece of data. So what I am going to do is I'm going to get back everything except that identifier. And it occurs to me now, and I'll just mention this as an aside, you notice that what I ended up doing is I said, I want to turn off the ID. I suspect I can probably do that in my find statement, and I will look into that, and maybe that will make it easier. That way I would not have to do this list comprehension. However, just for fun, let's remember this is a list comprehension. There's a for loop inside the square brackets. I'm going to get every status record in all of those status records. I'm going to go through them one at a time. And what I'm going to do is I'm going to do my remove internals, which is the thing that gets rid of everything that's an internal piece of data, which I have noticed is the things that begin with an underscore. If there was something else that didn't begin with an underscore, my code would not work correctly, but it does in my situation. So I returned this list of all of the records. And now the next thing we're going to do is we're going to look at the actual front end, the actual REST APIs that will be used by our front end. Okay, the last piece of code that we're going to look at. Remember, set host gets called by our monitoring REST API calls that come in, and so that's not a user interface thing, but get host status is. That's where we're going to return. This is not host, but this is for services. It's the same thing for all of them, that this is going to be calling into our REST API. So let's take a look at the REST API that does this. We're going to look at hosts. I've said this before, I'll say it again. It's the same exact thing for hosts as it is for services, as it is for devices. So what about my code? Well, remember, Quokka server is where I've defined all of my endpoints. So my endpoints live right here. I said that the request was going to be host/status, and it is. This is exactly the same as the other stuff that I've done before. If I go up far enough, then we can see at the very top of this, here is my hosts. So I didn't extend hosts to do something different, but rather I decided to create something new, which was going to be my host status endpoint, and that's what this is. This is just the same thing that we've done before. I remember I talked about rate limiting when we talked a little bit about denial of service. So I'm going to say there can only be 60 requests per minute, so that if every second somebody was getting at the information, I would, that's the maximum. And then this is, remember, that's what this is. This is for our protection against denial of service. This is for our Swagger, remember? This is our Swagger stuff. So we can use Swagger, and after I'm done explaining this endpoint code to you, then I will describe how I tested this using Swagger, because Swagger is so cool. All right, let's look at our GET request. We're going to expect host name to come in, and we're going to expect data points to come in. This is how we handle requests. We've gone over this many times. I'm not going to belabor that point. The host name is required. If it's not there, we return a message and an error. If they don't specify the data points, I'm going to say, well, we're going to give you 24. That just makes it easier. If you give me data points but they're not numeric, then I'm not going to be happy about that. So I'm going to send you an error and say data points must be an integer. Going down a little bit further, now that we're ready to do something, I'm going to try to get the host from the host name you gave me. So if your host does not exist in the database, get host, we'll just go and peek at that. That is my code here that actually just goes and gets the host from the database. So it gets the host. If we don't find it, then we say, we can't get anything for you. We don't know about this host. Otherwise, we're all ready to go. I'm just going to create my return data. My return data is going to be, as you can see, a dictionary. It will have 3 fields. One field will be host, which will be all of the detailed host information that I just gave you that ends up showing up as the IP address and the MAC address and all the other stuff in the output. We'll look at that in just a second. Status is going to be the actual numeric data. In fact, why don't I pull this up and why don't I go to hosts, and I am going to, I'll do Google Home because we've done that. So what is host? Host is going to give me in my user interface the host name, which I know already. It will give me the IP address in the user interface. It will give me the MAC address. It will give me the last heard, so I will know when it was last heard. This is actually kind of small. It looks a little bit better when it looks like that, but you get the general idea. And then here is my status. The status that is going to come back is going to include the response time and the availability, and it will give me the number of data points that the user has requested, or 24 if we did the default. And the summary, if you're not familiar with the original Quokka, that is going to be an hourly summary, which I will go through and have a task that runs in the background. And I think I've decided I will both do the summary and trim old entries from the database so that I keep my database nice and clean and uncluttered with extra stuff. The summary, I think we probably can let grow forever, but this minute by minute data, however often we're writing it, we probably don't want to be filling that up forever. You can imagine how big our database would get after a month or so. So that is what we are going to return. And as I said, it's the same for service status. It's going to look exactly the same, and for device status. Now, those of you that are familiar with Quokka, let me go back to here. If you're familiar with Quokka that I did before, and you go to devices and you look at the device data, you'll see, oh, that's a little bit different. I used to have CPU and memory. I'm not actually monitoring that in Quokka Prime. Maybe that will be something that I add. That is data that I get back from Napalm. But if you're not involved in the original Quokka, if you're not familiar with it, or if you're not that interested in devices per se, then you don't have to worry about it. Here's my hosts. Here's my services. Let's look at a graph for services. Let's look at HTTP, BBC. Availability is pretty good. Let's see if I can find one of these with availability that comes and goes. What about David Bombal? Is that always available? Yep, it's always available. But you can see the response time is like 1.5 seconds. Anyway, all right, did I cover? That's device status, service status, host status. This is how we get the status. This is the REST API. And now the next thing I'm going to do is show you how I tested it. So now that we've done this relatively small amount of code, or probably as you do it along the way, how are you going to test this thing? Well, one way to test it would be to just let the user interface test it by creating the user interface. That can sometimes be problematic because you're working on code in the user interface as well as the back end, and you're not sure which is messing up. So sometimes it's better to test just the code that you have just created. And therefore, if we want to do this, we can just make REST calls. Now, over here on the left, you can see Postman. We could do that, and we've done that before. But remember, the cool thing is we did this Swagger thing. So I'm going to go and try to exercise our Swagger API. So remember, it's localhost. Now localhost 3000 is going to get us at the actual user interface for Quokka. I don't want that. I want the REST API, which is on port 5001 in my environment. So I'm going to do this, and here's my Quokka. This is good news. It doesn't look, I don't know why this doesn't expand itself by default. I tried to figure out why it doesn't come up like that immediately. I know that in previous project I've worked on, it does that. I've not figured out how to get it to do that yet. That's my bad. But basically, this is my Swagger API. So now, hey, this is good. I could look at, I could get all the devices. I could also get device status. And since we've been dealing with hosts, let's say, get me the host status. So here, let me make this bigger just so that we can see more of it. This is my host status. So host status, my parameters, because I did that nice stuff here at the top where I defined what the parameters were, host name and data points. I'm able to be aware of them right here. And you'll notice when I hover over them, this is giving me the international no symbol. That's because I need to go into this mode where I'm going to be testing it out. So I click up here on try it out, and now I'm going to type in the host name. Well, I want to put in a host name, and so what I'm going to do is come in here and I'm going to go to Google home.home. I'm going to copy that. I'm going to come over here. I'm going to press my middle button to do that. I'm not going to pass in the number of data points. I'm going to let it default. And now I'm going to click execute, and let's see what happens. If it's successful, then it will come back and it will tell me, as you can see down here, the code was 200. That's good. And not only that, look at this beautiful data that I've got. This is showing me exactly what I got back. It's a dictionary. The first item in the dictionary is called host, and it has IP address, MAC address, host name, last heard, open TCP ports if I wanted to show that. It has my current response time and availability. That's all good, but really for the purposes of this, I'm interested in status. So what does my status look like? Well, it is a list. You can see that right here by the square brackets. And here, my friends, is every individual data point that I've gotten in the order that I believe I requested them. Notice this is 1034. This is going to be 1033. This one is 1032. This one is 1031. And it's going to keep going for, at least in theory, 24 of these. So I'll eventually get down to the bottom here, and then summary. You notice summary, I haven't done the summary yet, so that's empty. So you know what? When I look at this, I can say, that looks pretty good. I'm pretty happy with that. I think it's ready for me to begin writing the user interface. All right, so let's review what we talked about in this lesson. This lesson was about storing data over time so that we could create graphs like these in order to show what's been happening. And in these situations, we're talking about response time and availability for services, for hosts, and for devices. We talked about how we would be storing it in the database. There would be a new database table with underscore status at the end. So host status, device status, service status. And basically we just keep writing data to the database every time we make a recording. So the database ends up being filled with data from all of the different timestamps that we have received data in the network from our monitors. And so the code, in order to do this, we have endpoints that do the RESTful APIs. Eventually, they're going to come down and they're going to call get device status or get service status or get host status. The code that actually implemented it, we look at it in order to store the stuff in the database. All we needed to do was create an entry every time a monitor calls in to update the host, then set host gets called, and instead of, well, in addition to just updating the host entry in the host table, we're also going to add an entry to the host status table, and that will include time, host name, availability, and response time. We also have a new function that we created that was referenced in our Quokka server that we just talked about. We're getting host status in this situation. Here we get the host status. How do we do it? Is it difficult? No, it's quite easy. All we need to do is go into host status. We find based on the host name that we've been given. We sort it based on time in descending order, and then we limit it to the number of data points that have been requested, and then we run through this list comprehension in order to return the data to the caller, which is going to be this REST API function, and then we return it to the user. We also looked at using Swagger in order to test this. So that's what we did. Hopefully it made sense. If anything is unclear to you, please let me know in whatever way is appropriate for you. And thanks for watching.